Really excited to teach because I'm so sick of talking about syllabus stuff. Okay, so this is completely linear review, linear algebra. Okay, so first part, slope, rise over run. You know that. I just talked about it being y2 minus y1 over x2 minus x1. Totally review, that's embedded in your brain. Do you guys remember that little triangle? You remember what that means? The change of, very good. So you might write that in your notes and say, this literally translate to the change in a y over the change in x. Okay, so when you see that triangle in math, that's what that refers to. Okay, so let's do a couple examples. Okay, so you see number 1, it says to find the slope of that graph. Okay, so we're simply looking at the 2 points that are given to us, and we're looking at the rise over the run. So what do you see as the slope of that graph? How much does it rise? 4. So, and it goes down, right? So what do we know? It's a -4, right? So our slope is going to be -4. How much does it run? 3. So we're going to the right. 3 over 4. Can I reduce 3/4? No. That was easy, right? You remember how to do that? Okay, so for question 2, we're going to do y2 minus y1, and of course it doesn't matter which order you do it in as long as those points are correlating. So I'm going to do 0 minus 2 over -2 minus 4. So would anybody else agree that I get -2 over -6 and therefore a slope of 1/3? Okay, how about number 3? For number 3, I would have 2 minus 2 over 3 minus 2. So what do we get? We get 0 over 1. So what happens when we get 0 over 1? It's 0, right? Yeah, that's 0. Okay, so what do you know about a slope that has a slope of 0? What kind of line are we talking about? Horizontal. Okay, so horizontal lines have a slope of 0. So maybe write that in your notes. Horizontal line. What would the equation look like for this one? Is it a x equals or is it a y equals? It's horizontal. Y equals, right? So what's the y value? It hits every single time. Y equals, what's the y value always? Look at the 2 points. They're the same. Y equals 2. Okay. So remember, there's no x on a horizontal line. Okay. Number 4. Okay, so number 4, we get 2 minus 5 over 3 minus 3. So what happens here? What do we get for my fraction? -3 over 0. So what do we know about dividing by 0? It's not. It's undefined. Okay, so we can write undefined with a line slash through it, or you can literally write the word undefined. Both are acceptable notations. Okay, what kind of line are we talking about? Okay, vertical, right? So we got a vertical line. What's the equation of this line? Good. X equals 3. Perfect. Very good. We got this. Okay. Quick review on parallel and perpendicular. You guys remember that parallel lines have the same slopes. Okay, same slopes. Perpendicular lines have opposite reciprocals. Perfect. So you take it, you flip it, and you make it opposite. Okay, so here's a little example over here. The M1 slope is 5/2, so therefore the perpendicular slope would be -2/5. Okay. Totally review. Okay, so now here are your 3 forms. Notice that only one of these is highlighted. I find that interesting, don't you? Okay, so in calculus, they're going to ask you for equations of linear things. They will hardly ever tell you which form to leave it in, especially the further on we go. If they say write a linear equation or write an equation of this, you can put it in whatever form you want. And if you are given a slope and a point, that is what you're going to use most often in calculus. Okay, so this is the one you are going to see a lot of the time. Okay, you do need to remember slope-intercept form because they might go as far as saying, well, then put it into slope-intercept form. And the third form, I think, should be slightly new to you. In the past, you've seen the word, anybody? Standard form. So do you guys remember what standard form was? It was really close to this, slightly different. What was the difference? Equals c². Okay, so general form is just slightly different. It is set equal to 0. Okay, and a key piece, notice that it's underlined at the very end. What is an integer? It means what? No what? Number line, and no, more specifically, narrow it down. Yes. Getting closer. Can't write it as a decimal or a fraction. There you go. Okay, they have to be whole numbers. Okay, so it can be positive or negative whole numbers. That's what an integer is. So I'm going to say no fractions or decimals. Fractions or decimals. If I start writing too small, let me know in the back there. Okay, so that is just slightly different than something you've seen in the past. Okay, so here's what we just did. It says to find the equation that goes through the line 2, 3 and goes through this, has a slope of -3. So what do you think? What would be the easiest way to get this done? Yeah. Okay, we got a point, we got a slope. Let's throw it into point-slope form and be done. Okay, so what is my equation going to be? Y minus 3 equals perfect. Okay, so I would start with that scenario every single time. If they eventually said put it in slope-to-intercept form or something like that, then I would take that and manipulate it into whichever form they asked for. Okay, pretty straightforward on that one. Super big idea, super simple, right? Okay, don't make it harder if it doesn't have to be. Okay, we just talked about vertical lines. What's the equation for a vertical line going through the point -1 and 2? Very good, perfect. X equals, and just the X value, -1. Good. Ah, this linear stuff is so easy. All right, moving on. Here we go. Okay, so now we're doing parallel perpendicular. Okay. Number 7 says we've got a line that's got to go through the point -1, 2, and it's got to be parallel to that equation there. And then we're going to write that equation in slope-intercept form. Okay, so let's start with the beginning. If you see the word parallel, what do you need to be thinking about? The slope. Okay, so what is the slope of the line that's given? Can you look at that and tell me what the slope is? 2/5. Okay, now, what if I can't just look at it and just pull it out? How did you do that in your head? What do we need to do to find slope? Yeah, let's put it in slope-intercept form. It's totally fine if you can do this in your head. Okay, I'm just going to write it though anyway. So if I set it equal to y, I'd subtract 2x, right? So I'd have negative 5y equals negative 2x plus 5. Then what would you do? Divide each piece by negative 5, right? Okay, so the equation for this would be a positive 2/5 x minus 1. Okay, so I can pull the slope out of this. What's my slope? 2/5. Nice. Okay, so there's my slope. Now I have my point. I'm going to use a different color now because I'm kind of thinking differently here. What do? Got a slope, I got a point. Point and slope, throw. Yes, throw it right in there. So let's go y minus 2 is equal to 2/5 times the quantity of x plus 1. Okay, awesome. Got my equation. Am I done? Ah, dang it. Slope-intercept form. So what do? Change it. Okay, so carry out the 2/5. Good. Can I do a little like pre-work? Like I noticed that there's a 2/5, a fraction over there, and I'm going to have to work with fractions. So can I go ahead and change the 2 into fifths? See where I'm going with this? Because I'm going to eventually have to add it over. Okay, so 2/5 is the same as 10/5, right? So if I rewrite this, this will make my next step a little bit easier. Okay, if I distribute 2/5 through, this is going to be 2/5 x plus 2/5. So now what do? Add the 10/5. So if I add 10/5 to both sides, it sounds like fists, 10 fists. We get, how about 12 fists? Not fists. Fifths. Slope-intercept form. Okay, can I leave it like that? Can I have fractions in slope-intercept form? Am I okay with that? That's okay. No rules against fractions in slope-intercept form. Good to go. Okay, all right, so number 8. We got the same point as number 7, the same equation, but this time they're asking us to do perpendicular, which means what? Opposite reciprocal of the slope from the previous line, and I got to put it in general form, right? Okay, so where am I going to start? What is the slope of the other line? Okay, so if I'm given a slope of 2/5, what's the slope that I'm going to use for the perpendicular line? Negative 5/2. Good. Okay, so let's take that with the point. So where am I going to start? Y minus 2 is equal to negative 5/2 times the quantity of x plus 1. Okay, so there's an equation. Is it in the form they asked for? No. So general form, what do? Okay, so I'm going to distribute. Can I change that 2 again into halves this time? With a little, so that would be minus 4/2. Good. Okay, so we got, if I distribute the negative 5/2, it would be negative 5/2 x minus 5/2. So next step, I add 4/2. So if I add 4/2 to negative 5/2, what is that? Negative 1/2. Good. Let me know if I'm going too fast. Is everybody following this? Okay. And then I have to put it in general form, right? So what am I basically doing? What is my goal here? No fractions and set it equal to 0. Can I do 2 steps here? Are you guys going to follow this? How do I get rid of the fractions? Multiply everything by 2, that common denominator. So I'm going to pull everything to the left-hand side where I have that positive y. And at the same time, multiply everything by 2. Okay, ready? So I got 2 times y. That's going to say 2y. Okay, I'm going to add that x piece over and multiply by 2. So if I have 2 times 5 halves, that gives me, the 2's cancel 5, right? So I get 5x. So plus 5x, I'm adding the 1/2 over and multiplying by 2. So plus 1 equals 0. How do we do there? Did I go too fast on that? Did you guys follow that? Everybody's good? Give me a shout out if we're struggling. Good? Nice. Say that again? Oh, because I'm adding everything to the left-hand side. Okay, so for me to move this negative to this side, I'm going to add it over. And the same thing with this negative 1/2, I'm adding it to the other side to set it equal to 0. Does that make sense? Because I could also subtract the y to the other side. Then everything would be negative. So one answer could also be the exact opposite of that version, right? I could have negative 2y minus 5x minus 1 is equal to 0. That would be completely equivalent to that equation. Okay. Good? Okay. Okay, so drawing the lines. You guys remember how to draw these lines? So what would you do for number 9? Put it in the calculator?
Is it cover, like you're covered up?
Oh, cover method. Yeah, right. So it's in standard form. Okay, so you would do the cover method, but when I look at this, I go, ooh. You do, ooh. Like when you cover up the y, your x-intercept would be 9/2, which isn't really that terrible, but I still kind of go, eh. Because 9/2 is the same as, yeah, 3.5, which isn't terrible. So you could just be like, okay, well, that's 3/2, that's 3.5, so that's like right there-ish, right? And my y-intercept would be, so if I cover the x, what's the y? 9 divided by 3? 3. Okay, so we could do it that way, or the other way is I could put this into, sorry, that wasn't super straight, slope-intercept form. Okay, so I could go ahead and solve for y if I wasn't super happy. Like, what if my x-intercept was like a third, 1/3 or something? You know, that was not nice. It would be easier for me to graph it in slope-intercept form than do it that way. So am I okay with doing it this way and leaving it, or do you want me to convert it to slope-intercept and then draw it? Or do you guys feel like you're good with slope-intercept form? Anybody want a refresher? Going once? Going twice? All right. How do I draw y equals 2? What kind of line is y equals without an x? Horizontal. Horizontal up 2 units. Voila, that was easy. Although a little tricky, because you might have thought it was a vertical line. Okay. All right, so let's grab some 84s real quick. So they're in the box over there. Grab the yellow box. I'm gonna do this one with the 84. Okay, so I'm gonna assume, oh my gosh, that's so small. Hold on, wait for it. Ooh, it's like mini. How's that? That is way bigger. Can you guys see that if it's like that? Sorta. Yes, no, maybe so. Okay, so all this is asking us to do is just graph it in a window where we can see all of those critical values. Okay, so I'm going to type this into the y equals, and when I'm typing this, I should be thinking, what does this look like? Before I hit the graph button, I should know what kind of function I'm going to see. For the most part, at least on this one, you guys should know. If I'm typing this in as negative 0.2x cubed, what are you going to see? What is it going to look like?
Is that the John Travolta?
The John Travolta. Very good. Does anybody know what I mean by John Travolta? So only those of you that have had me in the past know what that means.
Palmer taught about you.
He did? He even used John Travolta? Oh, Palmer.
I remember doing that. Oh, I did not say that.
Oh yeah, you had me 2 years ago. That's why. Okay. So you guys have seen an x cubed function looks like this, right? If I become the function, it looks like this. Okay, now what do I kind of look like I'm doing? Well, I'm disco dancing, clearly. Yes. Okay, so if you have never seen the movie Saturday Night Fever, it is a movie starring John Travolta, and it's all about disco dancing. That's why I call the cube function John Travolta. It's very exciting. Okay, so you will see a John Travolta for this. So let's type this in and see if we see our John Travolta. So negative 2.2 x squared 1.6 x plus 1. Okay. Oh my gosh, my window is so not even close. That doesn't look like John Travolta at all. Okay, so I'm going to hit a zoom 6, so I go to a standard 10 by 10. Whoops. And I see a parabola. Anybody else got a John Travolta? Did I type this in wrong? Ah, okay. So we know it should look like a John Travolta, so I need to adjust the window so that I can see it. So we're just going to hit zoom out. We're going to choose option 3 and hit enter right off of the, there we go. That looks better. Okay, now we see something John Travolta-ish. We're still not low enough. We can't see that minimum value there, so we need to go lower. At this point, we could zoom out again, but we might get too far zoomed out horizontally. So I'm just going to go in and manually lower my Y value. Okay, so do you guys know where to go to manually lower that? You go to Window. Okay, so click Window. So right now we're at negative 40 to positive 40. We want to go lower on the Y because we want to go down, right? So what do you think? Negative 60? Let's give it a try. Negative 60. Oh, good guess. Nice. Perfect. Okay, so we can see all of those critical values. We see the maxes and the mins. Okay, so now we can draw a little picture. So we're going to go something like from here to here. From here to here. Okay, and I'm going to go from negative 40 to positive 40. And we went, our Y was positive 40 and our min was negative 60. And then draw the picture that you saw. Nice little John Travolta with his left arm up. Okay. So it says indicate the scale on the graph. Forgive the window settings. Okay, so make sure that you draw those mins max. Okay, so if you just drew a John Travolta on there, do you think you'd get that question right? No. If you don't tell me what the x values, the min and max values are, and the y's, I could be drawing any function. Some random John Travolta. Okay, so that's super important. Okay, number 12, how do I find zeros? Yes. Zoom. I think you're zoomed in instead of zoomed out. Try to zoom in, or zoom out, I mean. Is it a little better? Okay, you gotta go further left and further down. So you can zoom out again and you should see it. I'll come and help you here in a sec. Okay, let's keep going. So it says find zeros of that function we just graphed. How do I find zeros? What are zeros? The x is where? Where it crosses the x-axis, right? Okay, so we're just simply looking where this function is crossing the x-axis. Zero means, by definition, we took the function and we set it equal to 0. Okay, so that's why it's called a 0. Okay, so to do this on the calculator, this is what I kind of just did. So where is it, how many times does it cross the x-axis? It kind of looks like 2, right? One of them kind of looks like it could potentially bounce. Okay, so I'm going to do that one on the left first because I can clearly see where that crosses. So I'm going to hit second trace, and I'm going to do number 2. It's a 0. Okay, and I'm going to go far over to the left so that I'm left, left, left till my cursor is going to be above the y-axis. Come on. There we go. Okay, and then we're going to hit enter, and I'm going to go below the x-axis and hit enter. Okay, and hit enter on the guess. And did anybody else get negative 11.6? 4, 9, 8, 6. Okay, so here's a rule in calculus. What are you going to round to? 3 decimal places. Okay, so 3 decimal places. So for this one, we're going to set is negative 11 point, what was it again? 649. So the 9 would round up, so we're going to say 65, right? Okay. So what do you think about this other one? Do you think it goes up and crosses and comes back down, or do you think it bounces? What do you think? You guys already did it? I'm going to zoom in on that sucker so I can see it better. Go back and zoom in. Oops. Screw that up. Wait for it, wait for it. Okay, I'm going to hit zoom 6. Oh yeah, it definitely goes up and down. So I'm going to do second trace. I'm going to go to the one on the left first. Do the 0. Okay, so that one on the left has a slope that's going negative or positive. So I'm going to go, my cursor is going to go below on the left bound. Then I'm going to go to the right. Hit enter. Anybody else get a 0 of negative 0.406? Negative 0.406. Anybody not following me and can't remember how to do zeros? Everybody good? Okay, so last one, second trace. Looking at number 2 for the 0. Okay, so now we have a negative slope, so I'm going to start above the line. I'm going to hit enter. Go below the line. Okay. So anybody else get 1.056? 1.056, okay. 1.056. Done. Okay. So we got 5 minutes, so this is what I'm going to do. I'm going to save the last two problems for Tuesday to show you. So what I'm going to do is I'm going to give you the assignments that cover the stuff that we just went over, and then I'll show you guys how to do these last two, and I'm going to show these other two how to you on the Inspire. Okay, so bring your Inspires on Tuesday. So for homework, let's go through 18. Okay, so I want you to go 1 through 18. Calls. Okay, so I will want you to turn this in. Eventually I'll have you finish the assignment, so you'll do it all on one page. So write this on a separate sheet of paper, and then I'll just collect this from you when I collect the 1-1 assignment.
You just have to write the answers on a separate sheet, or?
No, show your work. Okay, so what you turn in to me is all the work that you took. So I want to see the work part. Okay.